Hello again. This is word problems number 2, and we're going to test 2. So let's see, it's going to be test 2, section 3. The first one we're going to do is number 10. And this is, I don't know, this is not quite a typical word problem, but it's one that I didn't classify earlier, but I wanted to go over it. So it says, which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? So we write y is greater than or equal to -1, and we are going right to our answers because, well, we have nothing else to work with. So A says y equals absolute value of x minus 2. You might look at these answers and say, well, what am I supposed to do with this? Let me write them all out here. So y equals x minus 2 squared and y equals x cubed minus 2. All right. Now, so the given information is that y should be greater than or equal to -1. Basically what we're doing, this could have been under plugin. This could be like a plug-in strategy here, because we do have to plug in answer choices to make this be true. So the most easy and obvious number that I can think of to work with is 0. So let's just plug in 0 for x and see what happens. I'm putting zeros over every x. Now, absolute value of 0 is 0, minus 2 is -2. That is not greater or equal to -1. That's out. 0 squared is 0. 0 minus 2 is -2 again. This is also not greater than -1. 0 minus 2 is -2. -2 squared. Hey, wait a minute. That would be 4. That's our answer. We don't even have to continue. As soon as we find one that fits this criteria here, we are done. But what the heck, 0 cubed is 0. This is also going to be -2, and D also won't work. Okay, quick and easy. I just wanted to make sure that I covered that one because it is a plugin. It's unusual. All right, let's do another one. Let's do number 15. So same test, same section. So number 15 says the expression fx minus 2 over x plus 3. And we write that out on our pages. X plus 3 is equivalent to which of the following? So this is a familiar, it should be familiar by now, because these equivalent questions are all over the test. Now, there are 2 ways to do this. And again, this is not exactly a word problem, but it is sort of, I didn't classify it earlier. So 2 ways. One is plug-in. So I think we'll start with plug-in. And as you know, I love the plug-in strategy. So let's plug in a number. Let's say we plug in 1. Okay, and then we get, I'll do it in red. I'll do it in black. We do 5 times 1 plus 2 over 1 plus 3. And we get 5 plus 2 is 7 over 4. So we get our answer and we circle it. And then we go to our answer choices. We're looking for any answer choice that's going to get us 7/4. Right away, we can see that A and B are not going to get us a denominator of 4. A, definitely not. And B already has a denominator of 3, so that's not going to work. We've got it down already to C and D. So C says 5 minus 2 over, and remember our x is 1, so it's going to be 1 plus 3, which gets us 5 minus 2/4, which is the same as 5 minus a half, which is 4.5, which is not 7/4. It's not C. It has to be D. We do not have to work through D because we have clearly proven A, B, C are not it. Okay? All righty. Let's see what else. Let's try number 16. That's a good one. And we're not using too much space here, so I'm going to continue. Up here, number 16. Okay, it says a sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. So I write down $3,000. That's the total. All right. The bonuses were awarded in amounts of $250 or $750. So I write that down as well. $250 and then $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses awarded? Now, keep in mind when they say one possible number or value, something like this, that means there are several possible values. So that means that you have some choices in the way that you do the problem. You're going to have to make some decisions. So let's start with the 750. And you can choose, we have one $750 award or two. I like two because it's going to get a nice even number. We get 1,500. So let's say we have $1,500 awarded in $750. Let's just write that this is a bonus. Okay, so times two bonuses is going to be $1,500. Now that means we have $3,000 total, and we're going to take away the $1,500 for the $750 bonus, and we have $1,500 left to award for the $250 bonus. See what I'm doing? See how I'm labeling everything and everything is clear. We started with the 3,000. We took this, let me do this in a different color here. We took this $1,500 and we put it here and we're subtracting it out from the total. That gives us $1,500 left. Now, if we want to find out the total number of $250 bonuses, we're going to just divide this by 250. And that is going to tell us how many bonuses we have of the $250 type. So I do $1,500 divided by 250. Oh, I have to do this. Oh, I'm putting down my calculator. I just realized this is section 3. So I have to do this long form. So what I'm going to do is take out those zeros to make it easier. And we're going to do long division. 25 into 150. We can't even do it that way. So we just do, well, I know this is going to be 100 and two more is going to get me 150. So this is going to be 6. So probably what you need to do is just, depends how good you are at math. If you get that 25 times 4 is 100, if you get that part and you know that automatically, and you know two more 25s is going to get you 150. So anyway, the answer here is 6, but it's not the only answer. It's only because I chose to do two $750 bonuses. I could have chosen 3 or 1. Okay, so that is that. Now we're going to go to section 4. Let me clear this off first. Let's go to section 4, and we're going to start right up at the beginning of section 4. So I'm going to change my pen color, and we're going to do, this is test 2, section 4, number 4 and 5. They go together. All right, now, first of all, you have to realize that they go together. So right up at the top of the page, it says, you see that dark line? There's a dark line and then an upside down triangle and then another dark line. And then they have blah, blah, blah. They have the problem. And at the bottom, they'll have another dark line and a right side up triangle, right? And these are the indications that we have a group of questions happening in between that. So, all right, so it says, and then it also says question 4 and 5 refer to the following information. So the amount of money a performer earns is directly proportional to the number of people attending the performance. The performer earns $120 at a performance where 8 people attend. I definitely want to write this down. $120, and that's for 8 people attending. Because I don't want to go back and have to read that again. Now, number 4 says, how much money will the performer earn when 20 people attend a performance? Now, this one, it's a word problem, but I could have classified it also as a proportion problem. This is a classic proportion. Remember, a proportion is where they give you 3 pieces of information. They give you 3 info items, and you have to solve for the 4th. Okay, so here they're giving you $120. We're going to have dollars here for 8 people. We're going to have people down on the bottom. We could also flip it. It doesn't matter as long as our other proportion, our other fraction is organized in the same way. So they're saying 20 people. How much are we going to make when 20 people attend? 20 is on the bottom, our x is here. And then we cross multiply. So we get 8x equals 120 times 20, which is 2,400. And it's okay if you do this on your calculator because we're now in section 4. So that's all good. We're just going to divide out that 8, and we're going to get 300. And 300 is our answer. That is C. Okay, so that's a relatively easy question. Let's go to 5, though. 5 says, we'll just do this. All right, number 5 says the performer uses 43% of the money earned to pay the costs involved in putting on each performance. All right, so 43% is in costs. The rest of the money earned is profit. So the rest of the money, rest is profit. What is the profit the performer makes at a performance where 8 people attend? Well, using a different color, we already said that up here that the given information is when 8 people attend, the performer makes $120. Okay, so we already know this to be true. So the total amount is 120. Now we know that 43% goes to costs. So the little question here is 43% of 120. And we know that 43% is 0.43 as a decimal, of is multiplication, and 120 is 120. So when we do this, we get 5160. Now, what did we just solve for? This is the key here. Because as you see, A says 5160. And the question is it the answer or not? Now, we took 43% of 120. 43%, again, I'll use, a different color. 43% relates to the cost. So what we have found out is 5160 is the cost of putting on the performance. The question is asking for the profit. And actually, I should have told you to do this before, but in the question where it says, what is the profit? Circle it. What is the profit? This is what we want. We want the profit. You could circle what is the profit or just the word profit. Okay, so A is not it. That is our little sucker answer, right? Because here it says the rest is profit after we put the 43% into cost. So what we do is we take that 120 and we subtract out, well, it's to put zeros in here. We subtract out the 5160. And what is left is going to be the profit. And that is 6840, and that is C. Okay, be very careful. This is why on every math problem, you really want to label everything. You want to write down all your notes, really take note of how I am doing it, because over 20 years of doing this, I really have discovered the organized way to be. Or if I'm not organized, I will make the same kinds of careless mistakes as you might make. I'm not a math genius. I just know the score. I just know how to do the SAT. I know how to master it. That's what I'm sharing with you. Okay, so let's see what else we've got. Let's flip the page and go over to number 8. All right, I'm going to clear all this out. All right, so we're still test 2, section 4, number 8. And this is a straight up word problem. In a video game, each player starts the game with K points and loses 2 points each time a task is not completed. So we stop and we write some notes. Start with K points and we lose 2 points per, I'm just going to say incompletion. Per each incompletion, we lose 2 points. If a player who gains no additional points and fails to complete 100 tasks has a score of 200. I'm just going to stop because they're piling on some information and I'm already starting to lose my way here. So I'm going toward the numbers. It says the player fails to complete 100 tasks. Okay, so I'm going to start there. So if you don't complete 100 tasks, and it says you lose right here. It says we lose 2 points per incompletion. We can take this 100 tasks, multiply it by 2 points, and we have lost 200 points, right? So we have lost 200 points. Now I'm going to go to the other number that in that same sentence. They have a score of 200 points. So they have a score of 200 points. And they've lost 200 points. Now the question is, what is the value of K? And K is the points they start with, right? So we go back up here. We're starting with K points. So the question here is, they've already lost 200, and they're starting, or they have a score currently of 200. So what did they start with? Well, if we've lost 200, that means we used to have those 200 points. So if we add them back in, we started the game with 400 points. D is our answer. Okay, a lot of people get this one wrong. They'll pick 0 because they'll subtract out instead of add. So you need to just kind of take your time a little bit with this problem and really reason it out. I find that it really helps to talk out loud. Now, I know you can't talk out loud on the real test, but you can whisper, you can plug your ears. And if you have watched if you purchase the writing section of Mastering the SAT video course, this is a strategy that I tell my students to use. I'm going to tell you now. Plug up your ears if you need to read any math problem out loud, and you can whisper. You'll hear that your voice resonates throughout your skull, and you can whisper really quietly and not disturb anybody. It's a great strategy. Okay, so let's go to number 15. Let's see if we want to do that one. No, I don't want to do 15. I want to do, let's see, 21. Let's do 21. That's a better one. 15 is actually a conversion of units, and I don't want to do that. So, number 21, straight up word problem again. A project manager estimates that a project will take X hours to complete, where X is greater than 100. So we're going to write X hours to complete. The goal is for the estimate to be within 10 hours of the time it will actually take to complete the project. Now, I would underline, I'm not going to write all that down, but take your pencil now and underline that sentence. The estimate to be within 10 hours of the time it will actually take. Now, that's the part that I would underline. Now, we read on. If the manager meets the goal and it takes Y hours to complete. So X X actually is the estimate. And I'm realizing that now because it says Y hours, it actually took Y hours to complete. And that if I say the same thing, it's like, wait, is it X or is it Y? So this is the estimate. X is the estimate and Y is the actual time that it took. Okay, which of the following inequalities represents the relationship between the estimated time and the actual completion time? Now, so it says, I'll just write a little bit. The estimate is supposed to be within 10 hours of the actual, which means that, let's just use a number line. Let's say this is the actual time. Within 10 hours means it could be y minus 10, right? On the number line, it would be down here, or it could be y plus 10. So we have this range over here. Now, which answer shows us the range? Oops, B, C, and D. Well, only D gives us a range, right? So it's between -10 and +10, which is essentially what I have here. Okay, everything else is sort of adding, like A is adding X plus Y. Well, we're not adding the estimated time to the actual time. That doesn't make sense. And B says, let's see, Y is greater than X plus 10. Well, it's not greater than. It could be X plus 10, but it could also be X minus 10, right? So that doesn't work. And C doesn't work for the same reason. It's not less than -10. It's going to be in between these, and D actually kind of says that. Even if you don't fully understand the Y minus the X, you can see that we have a -10. Let me get another color here. We've got a -10 and a +10, and we can see that something is in the middle of both of those, and that makes sense. So that would be kind of your shortcut understanding. You could also add the X to either side, right? It would cancel out here, and you'd get X minus 10 and the Y and the X plus 10. Okay, so the actual value is X minus 10, in between X minus 10 or X plus 10. Okay, let's move on. Let's see, we've got, let's go into the grid-in section here, and let's try number 34. I'm going to clear this out. Okay, so let's do number 34. And it says, in one semester, Doug and Laura spent a combined 250 hours in the tutoring lab. Okay, so we've got 250 hours total. If Doug spent 40 more hours in the lab than Laura did, how many hours did Laura spend in the lab? All right, now we want to define Laura and Doug. Now we want to ultimately do this with one variable because they relate to each other. Now it says Doug spent 40 more hours in the lab than Laura. So if we make Laura X, we can make Doug X plus 40 to represent the extra 40 hours that he spent. Now, added up, they said combined, right? So if we add these up, we get 2X plus 40. And the total, we already wrote, is 250. So we can now very easily subtract out the 40. We get 210. 2x equals 210. And then let's just divide it by 2. And we get 105 as our x. Now, in this question, they're asking how many hours did Laura spend? And when you see in that question, you see Laura, you should circle Laura so you know that you're solving for Laura. Now, this is fine. Laura is X, and we solve for X. So 105 is our answer for this question. But If they had asked you to solve for Doug, you would have taken that 105 and you would have had to add on the 40 and the answer would have been 145. Okay, so just always reread that question part and circle. If you really want to do it right, you will circle it and make sure that it's correct. All right, let's try. We've got the last two problems in this section. We need a lot of room for this, so I'm going to clear this out. We're going to do 37 and 38. And please clear. Okay, every once in a while, my thing doesn't clear. Okay, so I'm not going to worry about it. It will clear eventually. But for now, I'm just going to try to make myself some room. Okay, a little awkward, but we can do it. All right, now we have that indication here, right? We've got that line with the upside down triangle in the line, and we can see questions 37 and 38 refer to the following information. Okay, it says a botanist is cultivating a rare species of plant in a controlled environment, blah, 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 blah. I don't want to read it. There we go. Okay, yay. Okay, so we are back to 37 and 38. And I'm not reading that. I don't care. I'm just going to go right to the formula. So we have N, and I'm not going to write it all out. I'm going to shortcut. So NY is next year equals N this year plus 0.2. I'm just going to write 0.2 times N this year times 1 minus N this year over K. Wow. Okay, that's a crazy formula. All right, it says the constant K is the number of plants. All right, so I'm just going to write that off to the side. K is number of plants. All right, now we go to 37. It says according to the formula, so we're just going to be plugging numbers in and using our calculators to solve. What will be the number of plants 2 years from now? So 2 years from now, what are you going to do with it? You're going to circle it. 2 years from now. So that means not next year, 2 years from now. If K is 4,000. All right, so we are trying to find the N for next year. We're going to do this twice because next year is only 1 year from now. So we have N of this year. What does it say? Well, we don't know. Well, okay, now we're forced to read that beginning because we need to have some numbers, right? We go back all the way to the beginning and it says, a botanist is cultivating a rare species of plant in a controlled environment and currently has 3,000 of these plants. Great. This year is 3,000. So I want to point out what I did. I skipped over the reading because I don't want to read. But I will read when I'm forced to read. And here I was forced to read, or there would be not enough numbers to plug into the problem. Okay, so I went back and I was like, oh yeah, you know what? I did miss a number up there. Okay, now if you had, the other option is you wouldn't read the whole thing, but you'd say, hey, there's a number. Let me just make a note of the number. And then off to the side, you would have said, currently 3,000, and that would have been great. Okay, anyway, now we know our NTY is 3,000. So we're just going to plug that in wherever we see it. 1 minus 3,000. And our K, we say, is 4,000 according to this problem. So great. Now we slowly but surely work this out. Now, I like to cross out the zeros. This is just going to be 3/4 here. So we have NY equals 3,000 plus, this is going to be, if we work this out, this is going to be 600. And this is going to be, this is 1 minus 3/4. That's going to give us 1/4. Okay, so this is going to be, whoops, wow, I really messed that one up. Okay, this is going to be 3,000 plus 1/4 of 600 is 150, and that we need a zero there. And so next year is going to be 3,150. Now, if you put that down as your answer, you will be wrong, because remember, 2 years from now. So we have to do this whole thing all over again using now 3,150 as our NTY. Okay, so now instead of 3,000, we do 3,150 plus 0.2 times 3,150 times 1 minus 3,150 over 4,000. Okay, I'm going to cross out those zeros, but our math is going to be harder now. So we have to really make sure that we are kind of slow and steady and doing it properly. So let's see. I'm going to grab my calculator, and 3,150 times 0.2 is 630. That's nice. Times, well, let's see, 315 over 400 well, I'll just write it out step by step. Minus, this is 0.7875. Okay, and now I'm going to do the whole thing. Whoops, 630. And you should be doing this on your calculators right now. Don't wait for me to do it. And we've got 3,150 plus 133.875. And that's going to get us 32.84. I'm rounding it, okay? See, why did I round it? Because if we go back to the question, it says round your answer to the nearest whole number. So it's actually, this rounded up. All right, here's our answer, 32.84. All right. I'm going to clear it for 38. Now, 38 is a similar thing, but they're just asking us to solve for a different number. So let's see. We've got N, NY, NTY. We just write this over again, and we're going to be NTY 1 minus NTY over K. All right. Okay, so it says the botanist would like to increase the number of plants that the environment can support, so the population of the species will increase more rapidly. If the botanist's goal is that the number of plants will increase from 3,000 this year, so we have a 3,000 this year, to a 3,360 next year. So 3,360 is next year, 3,000 is this year. Okay, so we just plug in 3,000 is this year, and 3,000 is this year. What we don't know is the K. We don't know the number of plants. They're asking, that question is saying, how many plants must the modified environment support? So again, we just have a problem, and they're approaching it. They're asking us to approach it in two different ways. 1 minus 3,000 over K. Now this can get tricky, and this is the last problem in the section. So before we continue, I just want to say, because this is tricky and it's kind of a decent amount of work, you may decide that you're not going to do it. And you could just leave this blank or plug in some guess number. Okay, now we're trying to solve for K, so we're getting everything over that we can. Now the 3,000 is unattached, so we can get rid of that. So we have a 360 equals, now that 600 is attached here. You can't just divide that out. you need to distribute it. So we're going to do that. We're going to get 360 equals 600. That's this. And then we're going to minus, and that's going to be, I think we're going to do that on our calculator. It's going to be 1.8 million or 1,800,000 over K. And now actually we can subtract out this 600, because if something is multiplied, you have to deal with the distribution. But once it's not multiplied anymore, now it's 600 minus this. Now we can get rid of this 600. So this is going to be negative 240 equals negative, I'm just going to shorten that up, 1.8 mil over K. And if we put that over 1, we've got this kind of situation, right? We've got a negative, we can cross multiply, negative 240K equals negative 1.8 mil, and we divide that out, right? Divide that out, and we're going to get, let me write it down here, K equals 7,500, and that's our answer. Whew, okay, that is a lot of word problems. That is it. So take care, have a great day, take a deep breath, shake it off, and I'll see you next time. Bye-bye.